Alright, I'm Jacob Oakes, and this is my presentation on the automatic tip-up. So, you can play the video. This is how a normal tip-up works. This is like your standard, like pretty cheap one. You pull the line, it turns the T, and that sets the flag up. And the flag's on a spring on that, towards it over there. And they're simple, they're completely mechanical, the standard ones you buy. The T device to release the flag. The frames are usually made out of the molded plastic, but you can get them with wood. Those are the more expensive ones. And you can also get them, it's called like a cross style, and those are a little different. And then they fold up. This folds up to here. And my design is similar. Okay, like so. So this is my block diagram for what it'll kind of look like finished. The black is all frame, and then this is the T device here, and there'll be a little magnetic switch, which is the Hall effect sensor right here on that, and then the magnet will be on this, and then the Hall effect will be up here next to the motor. And then when that turns, it'll set the buzzer over here off, and it'll set these lights off, and then that's where the motor will be to turn the spool down here. There's a rod that goes through this whole thing that connects the spool to the motor. And then the LiDAR and the temp sensor will be on the side, and then there'll be a ribbon cable coming from this box here, which is the microcontroller, the battery, and the screen. And then you'll be able to see the screen because there'll be a plexiglass cover on the box to keep it watertight. And then this part will fold down to here, and this part here will fold up. Okay. And my budget, the LiDAR was the most expensive thing at 40 bucks, and then everything total was about 140. The motor was pretty expensive at 20, and the KL was given from the school, but that was 25. And then everything else was pretty much given by the school. I had to order the Hall effect sensor, which is the magnetic switch, and the buzzer, and the temp sensor. So the features that I have are the blinking LEDs to show there's a fish on. I got the LCD screen to tell you all the information like depth and the temperature outside. The motor to reel in the line and to let line out to about a foot off the bottom is where I'd like it to be. The frame's going to be made out of the Labs carbon fiber printing material. It's got the powerful battery bank, and the buzzer goes off at the same time the lights blink. And then I have the Hall effect sensor, the magnetic switch to set the lights and buzzer off when the magnet goes by it. And then the specs are, my lights are an LED strip, the same ones we used in Micro. And they'll be stuck to that thing that folds up. And then I have the KL25Z, same thing we used in Micro. The LiDAR, it sends out a laser, and then it calculates how far or how long it takes to come back, and then it gives you a number in centimeters on the distance. And then the motor, I have it running off, it says it's a 6-volt motor, but I have it running off 5 volts, and it runs just fine on that at 100 RPM. It'll be 100 RPM at 6 volts, but it's a little less than that. And then I have the battery bank, which I don't know why it doesn't work, but it theoretically should work, but when I plug it in, the Micro does not turn on. And then I got an extra loud marine buzzer that's running at 5 volts. The higher voltage, the higher or the louder it will be. And then I have the Hall effect sensor. So these are all my parts. That's the LED strip and the LiDAR. That's the buzzer, which I have covered, so it'll be a little quieter. That's the magnetic switch, and that's just a transistor. And then I have the motor, and then this is all the encoder and stuff on here. It's like a chip. I have the motor driver here. This is your output to the motor, and these are your 2 inputs and ground. And then this is your 5 volts and ground coming from the Micro. And then this is my PCB. It doesn't work yet. I don't know why I'm not getting 5 volts, but this is what it looks like. And then this switch will be threaded into the frame of the tip-up. And then this is the ribbon cable, and then everything else here looks as it will underneath the plexiglass. Okay. So for code, I didn't put all the code in. This is like the first half. The bottom half is just like all the functions and stuff like that for like what I have like the send frame here, so in the bottom it says what send frame is and what it does and everything. But I have like my includes and defines here and my initializations, and then I have, this is for the blinking LEDs. This section turns it on and this section turns it off. It's just all zeros. And so I have, if the magnet goes by, it turns the buzzer on, which is this, and then this section turns on and off the blinking lights. And then if you put the motor into forward, in the forward direction for any amount of time, that's how you shut the lights and the blinking off. And then you can catch the fish. And then I got this stuff here is what St. Dennis helped me write for the UART for the LiDAR to get that to work, and then all the stuff that allows this to work is all at the bottom, and that I just copied from his code because it's kind of like the stuff from the send frame. All right. And my schematic, this is the KL25 section here. This is the switch. So it's basically just grounding one side of the switch to each port, and that's what's telling it that it receives something. It's not like a voltage, it's just ground. This is for the LCD screen here. This is the temp sensor section. This is the ribbon cable, and I have 20 different wires going out, and only one of them isn't being used, and that's this ground here. This here goes to this section. That's the LCD display. This is my motor driver, which will be it'll be screwed to the inside of that box on the tip up. And then I had to do a lot of jumpers because there's some that I might have been able to put through, but the distance between these pins on the micro, they don't allow wires to go through. They're not thick enough, so it's kind of hard seeing I have all these pins to have roots for everything. And then this pin here, even though it says 5 volts right there and it's labeled 5 volts there, it doesn't label it as a jumper or anything, so I had to put another jumper there. And that's it for that one. So I got you can play this video of it working.
Yep. Okay, so I got a magnetic switch right here that turns on the buzzer and makes the lights blink. And it's shut off by putting the motor forward for however long. As soon as it recognizes that it's in, it shuts it off. And then I got reverse, but it only goes in reverse if I get under a certain number for the LiDAR.
I'm moving my hand up there.
The LiDAR
at like 100 above the LiDAR.
Show the screen here. This number here is how far away it's reading.
And that's the distance. That
and if it's under 100, I have it set up to be able to turn the motor.
And it swaps from 100 to 200. I think that was affected because it was directly under the light. But it is about 200, and when it popped up as 200, that's the actual number.
I can usually get it to go up to 3.
And I have my temp sensor. 2.96 is about room temperature, and I've got it to go up to 3. It said it ranges from,
So that shows it's
I
raising.
think it was 2.94 to 3.01.
That's pretty much it.
Alright, and then those are my waveforms for the motor. One's forward and one's reverse. Alright, next slide.
Yep.
And that's it. Any questions?
So, just to be clear, that what you were showing in that video was sort of all the parts working, but
Yeah.
it's not actually necessarily doing a tip-up function. Like you gonna rearrange some stuff, or is that?
Yeah, when I put the magnet next to the switch, that'll be the tip up function. That magnet will be on the T section, and when it goes by that switch, then then the lights will go off and the buzzer and stuff. But I couldn't actually show a tip up function because it's not on a tip up.
Yeah, have you 3D printed everything yet, or?
No, I have the design mostly done,
Okay.
but I haven't printed it yet.
Okay. Can you go back to your main schematic, and I was looking down when you were talking about the switch. Where's the main toggle switch?
Oh, this is it right here.
Okay,
It's got 2 sections.
Yep.
That's why there's 6 pins.
Okay, so you said something about it being grounded. What was that about?
Yeah, so the middle of this, it's momentary on, off, or on, off, on. So off would be just the middle's grounded, and then you switch it one way, and then that ground will be completed to the pin. So that'll tell the pin to be a 1, and in my code I have like if PTE 0 is a 1, then do this. And it's only able to do it while you're holding it, so the motor just doesn't go off all the time. It's only when you want it to go off.
Okay. All right. Any other questions?